Hey everybody, we're back for 11:22 to 24. I have to mention that this is the last bit of new information for chapter 11. If you look at the stamp sheet, there are problems 11 or sections 11.21 and 11.22, and these two sections are basically closure. So this is all determining what type of interval or test it is and carrying that out. I am not going to do videos for those, but I will provide solutions for these, and definitely email, or I can do a Zoom or whatever to answer questions. But there's no new information. Today is the last bit of new information for chapter 11. We are going to do problem 22 as notes. Our last piece of notes that we need are confidence interval for two sample difference in means. And then for 23 and 24, we're not going to do the whole problem out. What we're going to do is just kind of identify what type it is and if there's anything weird about it. And that is it for this. Okay, independent random samples. Oh, okay, so right off the bat it tells us independent random samples, which means that we know we're going to have mu1 minus mu2 instead of a mu-d situation with paired. Of marriage certificates were taken in 1950 and 2000, and the age of the male participant on each certificate was taken. Certificates with 2 men had 1 chosen randomly, while those with 2 women were discarded for this study. Graphs and summary statistics below show information about these samples. Okay, so I have A, it says compare these two distributions. Okay, just to note that they're super right skewed. You got a bunch of outliers. So as interesting as that is, we're not going to focus on that for this problem. Okay, what we are going to do is write down the summary statistics over here. So we have, in 1950, the sample size was 992. Sample mean was 24.43. That's pretty young. And standard deviation was 7.37. Okay. And then in 2000, you have 985 in your sample. The age had increased to 30.02, which is not surprising to me at all. And the standard deviation has grown. It's a little bit more spread out than it was in 1950. That makes sense too. 10.36. Okay. All right. Identify. We wish to estimate the difference in mean ages. I'm going to put mu 1950 minus no. I want to do 2000 minus 1950. But my whiteout seems to have escaped. Okay. My desk here is really interesting. Okay. So, we're going to make this 2000 minus 1950. That is for sure going to bleed through the page. Okay. Now, just for you people out there that just got a moment of anxiety about why I did that, the reason I did it was because I wanted to use positive numbers. I knew this was higher than this. Remember, it doesn't matter. Your interval would just come out with 2 negatives instead of 2 positives at the end. And what you're doing is you're looking to see if 0 is in the interval anyway. So it doesn't matter. I just wanted to do this for ease of subtraction to getting positive numbers. Okay. Mean ages of the male participant on a marriage certificate in 1950 and 2000, and did they give us a confidence level? Yes, 95%. At 95% confidence. Okay, conditions. Okay, so we have 2000, 1950, okay, scrolling back up to the problem, it says independent random samples. Okay, what does that mean? That means I have an observational study, which means that I have a sample size that I'm going to use for my independence condition times 10. So I have in 2,985 times 10 equals 9,850, less than or equal to all marriage certificates in 2000. And then I have 992 times 10, all marriage certificates in 1950. I feel like that's plausible. Okay, large counts. Oh yes, we have very large counts. 985 is greater than or equal to 30. So CLT applies. 992 is greater than or equal to 30. So CLT applies. Okay. Alright. This is definitely going to be a T-star interval. The reason is because I have S sub x for both of these two, and I do not have sigma, the population mean, or population standard deviation, I mean. So, okay, so we're going to scroll here just a bit. I'm going to get my formula packet. Okay, confidence interval equals statistic. Okay, the statistic in this case is the difference between the two sample means. So I'm going to write it like this. I'm going to write x bar 2000 minus x bar 1950. I put it in this order because that's the same order I used in the null hypothesis, and I put it in parentheses because I want you to see that that is the actual statistic, both of those subtracted. Plus or minus T star, again it's T because we have sample standard deviations. Okay, and then the standard deviation of the statistic, standard error, is the same one we used in the previous lesson. So sample standard deviation of 2000 squared over sample size in 2000 plus sample standard deviation in 1950 squared over the sample size in 1950. Okay. All right, let's plug in our numbers. We have 30.02 minus 24.43 plus or minus, okay, T star. All right, let's go over to the side and calculate T star. Let's go over to this side and calculate T star because I know my standard error is going to be big, so I'm going to put him over here. T star equals inverse T 1 minus confidence level divided by 2 comma degrees of freedom. Okay, so we get to practice this. This time my sample sizes are different. So I'm going to take the smaller one, which is 985 minus 1, and I have 984. Remember, it's the smaller one of the two minus 1 because you're being conservative. And that is 1.9624. Just want to quickly make a note here that this is extremely close to 1.96. Why is that? Well, it's because your sample sizes are so huge that the t distribution in this case is very, very much like the normal curve. Okay, so 1.9624 times the square root of, so I have 10.36 squared over 985 plus 7.37 squared over 992. Okay, great. And this simplifies out to be 5.59 plus or minus 0.7940. Again, as in the last video, please do this calculation on the calculator, which comes out to be 4.7960 to 6.3840. Conclude. We are 95% confident that the interval from 4.7960 to 6.3840 captures the true mean difference in age of a male participant on a marriage license certificate. It says certificate, it's fine, it's fine. In 1950 and 2000. Okay, so a couple of things. You would have just gotten these same numbers but negative if you had done 1950 minus 2000, and the important thing here is that 0 is not in the interval, which means that this is statistically significant, and that it's clear that men were either anywhere from 4.7960 to 6.3840 years older in 2000. And that did not just happen by chance. Okay, now let's go to 23. As I said, we're not going to do this whole problem out. What I want to do is just talk about what type of problem it is and if there's anything weird in it. Okay. Very large high school is planning to start an enrichment program to prepare students for SAT. Please tell me you guys are reading along. The principal decides to run an experiment. Okay, so that's your first thing. Notice that this is an experiment. I'm gonna flip this over. That's the first thing I'm gonna note. Experiment to see whether the program is worth the money. She gathers 20 volunteer students from the sophomore and junior classes and gives them all the same pretest. She then randomly assigns 10 students to a prep class and 10 students to a class that simply encourages them to prepare and provides free online resources. After 30 days in the class, she gives all of these students a post-test and measures the change for each student. The table below gives the increase in test scores for both groups. Okay. First, because this is an experiment and the words randomly, random assignment, is it randomly assigned, is in the problem, that means that you get to use this for random and independent. Okay, which is great. So you don't have to worry about the independence condition because there is not a random sample. It's random assignment of all of the volunteers. Next thing I want to talk about is that these are independent samples. This is not a paired situation, and the book, I think, is trying to make you think about this. It sounds like it's a paired situation because you have calculated differences and improvement, but there's a different group in sample 1 and a different group in sample 2. So you have the get prepped and you have the other class. And these are different students. Because they're different students, they're independent samples. Okay. Okay, the last thing that is interesting about this one is that the sample size is too small. So you have 10 is less than 30. What you need to do for the large counts condition here is notice they gave you the actual numbers for the score increases. So you're going to have to take group A and group B, put them into L1 separately or L1 and L2 and do one variable stats and create box plots. And you're going to have to look at those box plots for any extreme skew or outliers, and there won't be, because otherwise you wouldn't be able to do the problem. As bad as you might think it is, it's good enough. Okay, now 24. Oh, one more thing, back to 23. It says, do the data provide convincing evidence? Because it gave you alpha equals 0.10, that means you're doing a hypothesis test and not a confidence interval. So this is a hypothesis test for 2 independent samples, which would be this one here, problems 115 to 118 type. Okay, now number 24. Fitness trackers or electronic devices. You recruit 200 volunteers for a fitness study. Okay, so notice it says you have volunteers for a study, so that means you have an experiment again. And you have the words randomly chosen, which it just means random assignment. Okay, so you get to use that for the random and independent conditions. They're two different groups, so they're independent samples. In this case, you have a lot of people. You have 100 in sample 1 and 100 in sample 2. So you can use CLT, no box plot necessary, which is great. And then it says alpha equals 0.05. So it's a hypothesis test. Same procedure as number 23. However, you don't have to make box plots, which is great because you have 100 people in each sample. Okay, you guys, you do not need to do these out. You're going to be doing more of them in the closure problems and in the homework. So it's fine. I just wanted to point out differences, and then you would follow this process from problems 11, 15 to 18 for both of those problems. I will see you guys soon, and I will post the solutions for the closure as soon as I get them done. Thanks, guys.